So during the last years, I have been introducing some of the personalities up to 60 who developed the civilian industry through its works, papers, or inventions since the 17th century. Naval architecture and marine engineering have a rich history with many notable figures who have made significant contributions to the field. Some of the individuals who were celebrated for their achievements in previous presentations were, for example, Isambard Kingdom Brunel. So as you know, Brunel made substantial contribution to the naval architecture with his innovative designs for ships such as the SS Great Britain, which was the first ocean-going ship to be built entirely of iron and had a combination of size, power, and innovative technology that revolutionized the maritime engineering stuff. So another, I was mentioning about Isambard Kingdom Brunel, that was one of the personalities which I've been speaking in the past. That he revolutionized the ships. As I mentioned, the Great Britain was the first ocean-going ship to be built entirely of iron and had a combination of size, power, and innovative technology that revolutionized the maritime engineering. Another person who I explained was William Fraught, that was a British engineer and naval architect. And Fraught is well known for his work in ship design and hydrodynamics. He developed the concept of the Fraught number, which is normally used to predict the behavior of a ship in various conditions. And his research laid the groundwork for wooden or modern ships designs and testing methods. David Taylor was another person who I introduced in my previous conferences as a prominent American naval architect who is often called the father of the modern naval architecture, and he played a crucial role in the development of the US Navy ships design capabilities and established the David Taylor Model Basin, which became a leading facility for testing ships designs and aerodynamics research. I also mentioned about Howard Chappell, that was another American naval architect and curator who focused on the study and preservation of traditional wooden boat building techniques. And finally, I also mentioned about Hyman Rickover, that was a US admiral who is often referred as the father of the nuclear navy. So, as I mentioned in this second presentation, I will present some of the most notable people from the early times up to the end of the 17th century. As the presentation is scheduled for just 40-45 minutes, I need to pass quickly for every person. And as I explain always, not all the personalities have been naval architects or marine engineers. Some of them were Navy officers, mathematicians, or even industrial tycoons. However, all of them introduced important implementations on ship design and production, and these famous persons will be shown chronologically from the Bressan family around 15th century to the Badia family, is going to be the last one, is around 17th century. For those who miss any particular name in this presentation, simply saying that all who are here do matter, but not all who matter are here. So please do not complain do not mention your particular hero. So the first family that I'm going to mention about naval architects is going to be the Bressan family. It's indeed a renowned family of the Venetian naval architects who played a significant role in the maritime industry of Venice. And they were active primarily during the Renaissance period and were involved in the design, construction, and maintenance of ships for the Venetian Republic, which was a major maritime power at that time. One of the most prominent members of the Bressan family was Francesco Bressan. He was a highly skilled shipbuilder, a naval architect who worked on numerous important projects for the Venetian fleet during the 16th century. And Francesco Bressan's designs were known for their innovative feature and excellent craftsmanship, contributing to the success of the Venetian Navy in various naval engagement and trade expeditions. The Bressan family expertise in naval architecture and shipbuilding was crucial to the Viennese dominance of the Mediterranean and its extensive trade network across Europe and the Middle East. Their ships were renowned for their speed, maneuvering, and durability, making them highly sought after by merchants and naval commanders alike. So the Venetian measurements, like ships and other maritime nations, varied in size and designs depending on the era and specific needs of trade. During the height of the Venetian Republic maritime power, which spanned roughly from the 13th century to the 17th century, the Venetian merchant ships were typically designed to navigate both to the open sea and the shallow waters of the Adriatic and the Mediterranean Sea. Some of the characteristics of the measures and characteristics of the measurements were the length. The Venetian measurements range in length depending on their specific purpose and era, but they typically measure anywhere from the 20 to 40 meters. We are talking about 65 to 130 feet. In length, larger ships might exceed these dimensions, specifically those engaged on long-distance trade routes. The beam or width of Venetian ships varied but was generally proportional to the length of the vessel, and typically beams might range from the 5 to the 10th meter. The draft had a relative shallow draft to enable navigation through the shallow waters of the Adriatic Sea. Normally, the draft might range from 2 to 4 meters. The tonnage of the ships varied widely, with smaller vessels measuring in the range of tens of tons and larger ships potentially reaching several hundred tons. The armament, while the merchant ships were primarily designed for trade, they were often armed for defense against pirates and rival powers, and the Venetian ships might have been equipped with cannons or other types of artillery, as well as small contingents of armed crew members. So I would like to mention that there were different types of ships in the Venetian times. So the terms long ship or round ship is normally how they differentiate on that time, the typical tips, is the historical classifications used to describe two different or distinct types of ships that were prevalent during different periods of maritime history. The long ship, often referred to as a long ship or dragon ship, was a type of naval vessel used by the Vikings during the Viking Age, and the long ships were characterized by their sleek, narrow design with a shallow draft that allowed them to navigate from both open seas and shallow rivers. They typically featured a single mast with a square sail and were propelled primarily by oars, making them highly maneuverable. Long ships were used for a variety of purposes, including raiding, exploration, trade, and warfare. They played a significant role in the expansion of the Viking influence across Europe and obviously beyond. The round ships, the term round ships, is often used to describe the typically sailing vessel of the medieval and Renaissance periods, characterized for the round or broad hull shapes. Round ships were designed for long distance trade and explorations, and they were capable of carrying large cargoes across oceans. These ships were more stable in rough seas compared to the long ships, thanks to the broader hulls, and they typically had multiple masts with a square of latent sails. Round ships played a crucial role in the age of the explorations, with the Spanish, with the Portuguese navies, facilitating trade routes between Europe, Asia, Africa, and the Americas. They were instrumental in the colonization and the global expansion of European powers during the 15th to the 18th century. While both longships and roundships were significant in their respective eras, they differed greatly in design, purpose, and historical context. So the Venetian arsenal, or the Arsenale di Venezia, is one of the most historical significant shipyards in the history and naval complexes in the world. It is currently located in Venice, Italy, and has played a crucial role in the maritime power and economic prosperity of the Venetian Republic. If someone is lucky to visit Venice, I recommend to visit the part that now is part of the museum. So the arsenal was founded in the 12th century, making it one of the earliest and largest industrial enterprise in Europe at that time, and it was established to support Venice's growing maritime ambitions. The arsenal was a vast complex comprising a network of different shipyard, workshop, warehouse, and administrative buildings, and its layout was designed for efficiency and productivity with specialized areas for different stages of shipbuilding and repairs. The Venetian arsenal was known for its innovative shipbuilding techniques and production methods. It introduced the assembly line, the manufacturing methods, processes, standardized ships components, and employed skilled artisans and craftsmen from various parts of Europe to ensure the high quality of the construction. And talking about the people who built this type of ships, I'm going to mention the arsenalotti. Arsenalotti refers to the workers who were employed at the Venetian arsenal during its heyday. These workers were skilled artisans, craftsmen, and laborers who played a crucial role in the construction, maintenance, and repair of ships for the Venetian Republic Navy. The term arsenalotti is derived from the word arsenal, which refers to the arsenal complex itself, and the arsenalotti were organized in various specialized guilds and labor units, each responsible for specific tasks within the shipbuilding process. These tasks include carpentry, blacksmith, rope making, sail making, and other trades necessary for construction and outfitting ships. The arsenalotti were highly skilled and experienced workers who took pride of their craft. They were known for their efficiency, precision, and ability to produce high-quality vessels that contribute to the Venice dominance as the maritime power in the Mediterranean on that centuries. The Venetian arsenal was renowned for its innovative production methods, and as I mentioned, were instrumental in the success of the Venetian Republic in order to play a crucial and vital role in shaping the Venice maritime history and legacy. Several prominent families played crucial roles or significant roles in the Venetian arsenal, also in the history, contributing to their success and the maritime power of the Venetian Republic. Here we can see some of the most important dynasties in this slide associated with the Venetian arsenal. Here we have the Teodoro dynasty, the Bressan dynasty. As I'm going to mention in the last slide about the Bressan, I'm going to quit, but there were other families, like, for example, the Mocenigo family was one of the most influential noble families in Venice, and several members held prominent positions in the Venetian government and military. They had a strong presence in the arsenal, and with many family members involved in shipbuilding and naval affairs. One of the most notable members was Albis Mocenigo, who served as a senator and commander of the Venetian fleet. Also, we have the Contarini family, was another prominent Venetian family, and other members contribute to the shipbuilding trade and diplomacy in Venice. The Dandolo family was another important family. One of the most important members of the Dandolo family were Enrico Dandolo, that serves as a dock and lead of the Venice during the Fourth Crusade. The Corner family as well is another influential noble family in Venice. And finally, the Barbaro family was another family who played we can say, a contribution to the role of the defending Venice maritime interest. So these families were just a few among many others that has significant influence and involvement in the Venetian arsenal, and they help to save Venice maritime power and ensure the success of the arsenal. So finally, I would like to mention about Leonardo Bressan. As I mentioned, member of the prominent Bressan family of the Venetian naval architect, is known for his innovative contribution to shipbuilding and particularity for his development of the barge design. The barge was a type of warship developed in the late 15th century by Leonardo Bressan, and this vessel was designed to address the specific challenges of naval warfare in the Adriatic Sea, where Venice should to maintain dominance against rival power. So some of the key features of the barge included a distinct hull design, has a unique hull design characterized by a sharp bow and slick lines, which improve its speed maneuverability. And this design was well suited for the Adriatic, relative shallow waters and varied waters conditions. The armament was armed with cannons and other artillery, and obviously the versatility. This barge was designed to be versatile, capable to both naval combat and also patrolling duties. And as mentioned, Leonardo Bressan's development of the barge design contribute to the Venice continuous maritime dominance and maritime success during the history. So we are going to move quickly to our next person. John Napier of Merkiston was a Scottish mathematician, physics, astronomer, and inventor, best known for his invention of logarithms and his contribution to the development of mathematical techniques, including Naperian logarithms and Napier's bounds. Some of his or we can say his early education, or we can say some of the concepts that he developed, was the introduction of the concept of logarithms in his work. If I do not remember wrongly, the name of the book was Miri Fini Logarithms Canon's Descriptions of the Marvelous Canon of the Logarithms, published in 1614. And this book published was Logarithms and Mathematical Functions that simplify calculations by converting multiplications and divisions operations into addition and subtraction, respectively. This invention revolutionized the mathematical computation and had a significant implications for various fields, not just for navigation or shipbuilding, also for astronomy. So Napier's logarithms, also known as Naperian logarithms, were the first logarithms system to be widely used. They were based on the natural logarithms with base e, and where e is the Euler's number. Later on, we will talk about this number. Is about 2.71828. So Napier's logarithms paved the way for the development of logarithms tables, which were essential tools for mathematicians, scientists, and also engineers before the advent of the modern computer. So in addition to the logarithms, Napier invented a mechanical calculation device known as the Napier bones or Napier rods. This device consisted of a set of rectangular rods or bones, each engraved with a set of rectangular, we can say, multiplicational tables. By aligning the rods, users could perform multiplications and division calculations quickly and accurately. They can get a results. So the Napier's bones were widely used for centuries as aids in mathematical computations. Other contributions, for example, Napier Napier made significant contribution on other areas of mathematics, including spherical trigonometry and algebra. He also worked on the development of astronomical instruments and methods for calculating the positions of celestial bodies. That's a very good development for navigation. And we can say finally that John Napier's work laid the foundations for many mathematician techniques and tools that we still use today. His invention of logarithms and the subsequent development of the logarithms tables had a profound and deep impact on shipbuilding and also facilitated complex calculations and advancement of various fields. Another person that I would like to highlight is Phineas Pett. Was an English shipbuilder and naval architect who played a significant role in the development of the Royal Navy during the early modern period. He came from a family of shipwrights and naval architects, with his father, Peter Pett, also being a renowned shipbuilder. So Phineas Pett, following his family, we can say his father's footsteps, and pursued a career in shipbuilding. He apprenticed under his father, who was the master shipwright at Deptford Dockyard, and Phineas Pett gained valuable experience and expertise in ship design, construction, and maintenance through his work in the dockyards. Pett is credited by introducing several innovations and improvements to shipbuilding techniques during his career. He implemented advancement in hull design, rigging, and construction methods, contributing to the efficiency, seaworthiness, and firepower of English naval vessels. Phineas Pett played a crucial role also in expanding and modernizing the Royal Navy during the reign of King Charles I. He was involved in the construction of numerous warships, including the Prince Royal, which was one of the largest and most powerful ships of that time. Pett was a prominent person on that time, and he also pushed for naval reforms aimed at enhancing the Royal Navy's capability and efficiency. He advocated for standardized ship designs, improved shipbuilding techniques, and better training for sailors and shipwrights. His effort contributed to the professionalization and modernization of the English Navy of that time. His contribution to the English shipbuilding and naval architecture has a lasting impact on the Royal Navy's development. His designs and innovations helped to establish England as a formidable naval power and laid the groundwork for future advancements and marine techniques. The next one is going to be Cornelius Drebbel, was a Dutch inventor, engineer, and we can say is well known for his contribution to various fields, including optics, chemistry, and pneumatics. He's particularly famous in our world in the shipbuilding for his work in submarine technology and his advancement in the construction of navigable submarines. Drebbel was born in Alkmaar in Netherlands in 1572, if I do not remember wrongly. Little is known about his early education, but he likely received training in the fields of mathematics, engineering, and alchemy, which were common pursuits among scholars of that time. Drebbel is credited with inventing one of the most earliest navigable submarines in 1620. He successfully demonstrated a submersible vessel on the River Thames in London. His submarine, which was propelled by oars and operated using a system of ballast tanks and pumps, could dive and resurface at will. Drebbel's submarine was reportedly capable of remaining submerged for several hours and reaching depth up to 15 feet. In addition to his work on submarines, Drebbel made a significant contribution in other areas of science and technology. He developed, for example, improvements to science, for example, in optical instruments, such as microscopic and telescope, as well as the thermometers and other scientific instruments. He also conducted experiments in chemistry and alchemy, although many of his academic pursuits were considered pseudo-scientific by modern standards. Drebbel enjoyed the patronage of several royal figures, including King James I of England and the Prince Maurice of Nassau, who supported his research and innovations. I'm going to pass to a French naval architect, François Coulomb, the father. We need to differentiate because later on we will see his son was a French engineer, a military architect known for his contributions to fortification designs and military engineering during the late 17th century, early 18th centuries. And he is sometimes referred to as the father of the military engineering due to his influential role in shaping the field. François Coulomb was born in France in 1654, and he received a formal education in engineering and military architecture, likely through apprenticeship and training programs available at that time. Here I mentioned the Arsenal of Toulon, Toulon is one of the most famous arsenals in Europe at that time, as the same thing that I explained, that the Arsenale, Venetian Arsenal is very important for shipbuilding in Venice. We have that the French, they have the Toulon Arsenal. It's also important mention that Coulomb made significant advancement in the design and construction of fortifications. He also, as I mentioned, developed innovative techniques on fortifying cities, castles, and military installations, incorporating principles of geometry, physics, or military strategy into his designs. But also, he's very famous for his contribution in writing in the shipbuilding. So Coulomb served in the French military as an engineer and military architect, rising to prominence for his expertise in the design and construction of vessels. He was involved in numerous military campaigns and six where his works played a crucial role in defending strategic positions and repelling enemy attacks. Some of these contributions beyond this type of designs were also in techniques for defense. Here we can see some of the warships that he designed during that period, some of the drawings that we can recover from that time. And we can say that Francis Coulomb work had a lasting impact on the field of military engineering. Here, for example, we can see where was the contribution during the 17th century in the ship design in France. Some of the most important designs was the Royal Louis or the Saint Philippe. Finally, overall, François Coulomb's expertise in the design and military engineering made him a significant figure in the history of military architecture and defense. And one of the key points is he was the father of François Coulomb, who was also a French military engineer and also cartographer, known for his significant contribution to the field of the military engineering and also shipbuilding. He's sometimes often oversaw by his more famous brother. I have preferred to quit Charles Augustin de Coulomb. He was another physicist who worked in electricity and magnetism. But François Coulomb is important for us for his contribution in the naval architecture. François Coulomb was born in Angoulême, France in 1691, and he likely received a formal education also in engineering and military architecture, possibly through military academies and apprentices with experienced engineers, as for example, one of the academies that there were in Toulon. Coulomb pursued in his career in the French military, serving as military engineer, and Coulomb made significant contribution to the design and construction, again, to different ships. He developed significant innovations and techniques in order to build and design, for example, ships like the Terrible, or also the Tonnant, as well as other ships that fight against this type of ships, as for example, the Triton. I'm not going to mention his expertise on the cartographer because the time is quite strict. So I'm going to move to the next one that probably is the most important French naval architect in the history. His name is Henri-Louis Duhamel du Montchoix, who was a French physicist, naturalist, a polymath known for his contribution to various fields, including the botany, agriculture, forestry, and naval engineering. He was a prominent figure of the Englishman period and made significant advancement in the understanding and application of scientific principles in the shipbuilding sector. Duhamel du Monceau was born into a noble family in Paris in the 1700s. He studied medicine at the University of Paris and obtained his medical degree in 1721. However, his interest extended far beyond medicine, and he dedicated much of his life to other aspects, as for example, the ship design. Important, Duhamel du Monceau made important contributions in the fields of the botany and agriculture, as I mentioned previously, and he conducted extensive research on plant physiology, growth, and reproduction. Of his work helped to improve agricultural practices and crop yields. And he wrote several influential books at that time, but that's not the important for us. The important for Duhamel du Monceau is on the shipbuilding sector. And he also made significant contribution to the naval engineering and shipbuilding. He conducted research on ship design, construction materials, and naval architecture, aiming to improve the performance, durability, and seaworthiness of the ships. His work helped to advance the French naval technology and strengthen the French maritime capabilities at that moment. He is considered several times as the father of the French naval architect. So his contribution exemplified the spirit of that time and emphasized on empirical inquiry, rationality, and practical application of the scientific knowledge. He was also the person who implemented the naval architecture studies in France. Later on, in countries like Spain and UK, they inherit the improvements that Monceau implement. So the next one is another French naval engineer and architect, known as for his significant contribution to the shipbuilding and naval architecture during the 18th century. René Nicolas Lavoisier played a crucial role in the modernization and improvement of the French naval vessels, particularly during the reign of the Kings Louis XV. And some of the improvements, for example, were the study of the sailings in shipbuilding. So Lavoisier was born in France in 1705, and he received a comprehensive education as well in mathematics, engineering, and also in naval architecture. That was one of the, we can say, first scientific methods that was applied in our sector. So he also was apprentices at training programs available at that time in the shipyards, and he embarked on a career in naval engineering, served in various roles with the French Navy, and he quickly gained recognition for his expertise in ship design, construction, and maintenance, and he was appointed to important position with or within the naval administration. Here we can see part of the family, and we can say how all the family has been devoted in several cases to the shipbuilding sector. Lavoisier, as I mentioned, made significant contribution to the design and construction of the French naval vessels. Here in this slide, we can see some of the vessels that he designed and per different years. He introduced innovations in hull design, rigging, propulsion systems, and armament as well, aiming to improve the speed, maneuverability, and firepower of the warships. His designs were instrumental in enhancing the performance and effectiveness of the French Navy at that moment. So Lavoisier also played another key role in the modernization and expansion of the French Navy during the 18th century. He worked closely to the naval authorities and government officials to implement reforms and improvements in shipbuilding techniques, naval infrastructure, as well as maritime strategy. His effort, as I mentioned, helped the French maritime capabilities in order to maintain its status as a major naval power at that time. Overall, René Nicolas Lavoisier's expertise and leadership in naval engineering played a crucial role in advancing the French naval capabilities and ensure the effectiveness of the French Navy. The next one that I would like to mention, I already anticipated when I was talking about Nepper, was Leonhard Euler. All of you know him, was a Swiss mathematician, physicist, astronomer, logician, and engineer who made significant contributions to numerous fields of mathematics and science during the 18th century. He's widely regarded as one of the greatest mathematicians of all the times, and is also known for his prolific outputs and profound impact on mathematics, physics, and engineering. So what is less, we can say, known is his relationship with ship design and shipbuilding. So Euler was born in Basel in 1707. He showed us an early aptitude for mathematician and began studying the subject intensively at the University of Basel. And despite losing sight in one eye as a child due to a fever, Euler persevered in his studies and pursued into a career of mathematician. Here in this slide, we can see some of the bibliography of Euler. Most of you knows some of the books, made a groundbreaking contribution to various branches of mathematics, including calculus, number theory, algebra as one of the books, geometry, mathematical analysis. He developed important concepts and techniques that we are still used today, such as the Euler formula, Euler's identity, Euler's graphs, and the calculus of various. Euler made significant contribution to the study of infinite series, differential equations, and number theory. However, something that for me is important is his contributions to the naval architecture. Here we can see the three most important: the Traité du Navire, the Scientific Navalis, the theory or the complete theory of the shipbuilding and maneuvering of the ships. So we can see that Leonhard Euler's contribution to mathematics and science have had a lasting importance and impact on numerous fields. He is regarded as one of the greatest mathematicians of all times, as I mentioned, and his work continues to be studied and admired by scholars around the globe, as, for example, the equation of Navier-Stokes that, in certain way, thanks to the contributions of Euler, is part of our, we can see, theory or background of our studies in naval architecture and ship design. The next one is Thomas Simpson. Probably this is one of the most well-known. He was an English mathematician known for his contributions to calculus numericus analysis and also to mathematical physics during the 18th century. He made significant advancement in the development and application of mathematical techniques, particularly in the field of numerical integration. And we can see some of his contributions. As you can see that we are moving more to the 18th century. We can see people who work on the shipbuilding and ship design. There are many contributions, and not just in our field, also in other fields, as for example in mathematics. Simpson is best known for his development of numerical integration methods, particularly the Simpson's rules, and also his contributions, his books. The Simpson rules, all of you are aware of that, is a technique used to approximate the value of a definite integral by dividing the interval of integration into smaller subintervals and approximating the area under the curve using polynomial interpolation. We can say that Simpson rules provide a more accurate approximation than other numerical integration methods at that time, making it widely used in scientific and engineering applications. Probably some of you were taught in the university these such methods. Simpson published several influential works on mathematics and physics during his lifetime. His most notable publication is The Doctrine and Application of Fluxions, which presented his methods for numerical integration under approximation in calculus and mathematical physics. And Simpson's work helped to popularize the numerical methods and laid the foundation for future developments in numerical analysis. Finally, Thomas Simpson's contribution to numerical analysis and mathematical physics has a lasting impact on the development of the mathematics and science, and also the engineering that is our field of action. So now we are going to move to a Spanish character, was Antonio de Ulloa y de la Torre. He was a Spanish scientist, explorer, a colonial administrator known for his contribution to various fields, including astronomy, geodesy, natural history, and also mineralogy. He is best known for his participation in the French geodesic mission to Peru, and his subsequent work on the scientific exploration and study of South America. So for the people who is not aware of this person, he was working on that expedition along with Pierre Bouguer, that is well known as the father of the naval architecture. Antonio de Ulloa was born in Seville, Spain in 1716, and he received a comprehensive education in mathematics, natural science, and engineering, as the people on that period normally had. In 1735, Ulloa was selected to participate in the French geodesic mission to Peru, led by the French Academy of Science. This is why Pierre Bouguer was the leading actor of that scientific mission. And the mission itself aimed to measure the length of a degree of latitude near of the equator to determine the shape of the Earth. Ulloa served as a naval officer and scientist during the expedition, conducted astronomical observations, geodetic surveys, and also natural history studies. During his time in South America, he conducted several extensive scientific explorations and made important discoveries of various fields. One of them, for example, was in the part of the geology, flora and fauna, but also is very famous, and this is why I bring Antonio de Ulloa to here, because he was working on the shipbuilding sector, introducing, we can say, contributions to the shipbuilding and naval architecture. So we can say that the next one is going to be Gabriel Snodgrass, was a Scottish naval architect and shipbuilder known for his significant contributions to ship design and construction during the 18th century. He played a crucial role in the development of the British naval vessels and made advancement in the shipbuilding techniques, particularly in the design and construction of warships. We can say that he was a shipbuilder and one of the first surveyors to the East India Company. I'm not going to enter in detail about the East India Company, but I can explain that the Gabriel Snodgrass is very little known about his early career, early life, and education, but the author considers that he received training in shipbuilding and naval architecture through apprenticeships and practical experience in shipyards and dockyards. Snodgrass pursued a career as a naval architect in shipbuilding, specializing in the design and construction of warships for the British Royal Navy, and he is very, very famous introducing the diagonals stiffness that we can see in this model. He worked in several shipyards and dockyards across Scotland and England, gaining expertise in ship design, structural engineering, and maritime technology. His contributions to the ship design were enormous, made significant his contribution to the design and construction of the British naval vessels. He introduced innovations in the hull design, in the rigging, as I mentioned, aiming to improve also the structural resistance of the vessels. His designs were instrumental in enhancing the performance and effectiveness of the British Navy of that period. So Snodgrass was involved in the construction of numerous warships, including ships of the line, frigates, and sloops. He worked closely with the naval authorities and government officials and military commanders to ensure that the British warships met the requirements that the customers, the Royal Navy then, and were capable of fulfilling the roles in the warfare. So Gabriel Snodgrass' contribution to shipbuilding and naval architecture, as I mentioned, had a big impact on the British Navy and the maritime history. John Peck was another English engineer and inventor known for his contribution to the civil engineering and also transportation infrastructure during the 18th century. Peck, in this case, John Peck, particularity in historical records, he is believed to have played a significant role in the developments of the canals and inland waterways in England during the Industrial Revolution. And for example, he contributed to the construction of the Minerva, also to the Hazard, the Mareschal, and the Belisarius. So there are many ships that on that time, clippers, for example, they conquer the seas and make and huge improvements on the trade thanks to the shipbuilding. We are closing to the last characters, to the last people. Simon Stratego was a Greek mathematician, astronomer, and philosopher who made significant contributions to the astronomy and education during the 18th century. He was an influential figure to the intellectual and scientific circles of his time and played a key role in the domination of scientific knowledge in all Mediterranean countries. And for example, we can say that he was, I would like to bring to the first character that was the Bressan family and mention that Stratego was working on the arsenal, made a lot of improvements regarding navigation, and also working in contribution regarding a theory of Euler, or bringing the Euler theory to the shipbuilding, as well as other books regarding shipbuilding education. I would like to mention José Romero Fernández de Landa because he was the first naval architect in Spain. When I refer the first, is because in 1772 was when in Spain was created the Naval Architect and Marine Engineering Studies. So José Romero Fernández de Landa was a Spanish engineer, naval architect, and military officer known for his significant contributions to the fields of civil engineering, naval architect, and also military fortifications. José Romero Fernández de Landa was born in Spain in 1735, and he likely received a formal education in engineering and naval architecture. And he's so famous because one of his major contributions in 1784 that we call the Reglamento de Maderas, that more or less is like the regulations of the good, because at that time, the good that was provided, the timbers, the parts of the ship that was provided, they didn't have the quality that was expected. He was involved in numerous projects. In one of the most important was the standardization. It's something that started at the mid of the 18th century, but he played a crucial aspect of his career in order to work on the standardization. And as well, part of his contributions made, for example, with this ship, the Santa Ana is one of the most famous ships that he designed, as well as the San Ildefonso. So he had many ships from different sizes. So he's one of the most famous naval architects in Spain. Marmaduke Stalkart was a British naval architect and shipbuilder known for his contribution to the design and construction of naval vessels during the late 18th century. Marmaduke Stalkart was born in Great Britain in 1750. Is very little known about his early career, early life, and education, and it's expected that he received practical knowledge and experience in shipyards and dockyards. Stalkart pursued a career as a naval architect and shipbuilder, specializing in the design and construction of warships for the British Royal Navy, and he worked in various shipyards and dockyards across UK, gaining expertise in ship design, structural engineering, and maritime technology. Stalkart made significant contribution to the design and construction of different vessels, and he was renowned as a very good naval architect. He was, I mentioned, in some of the warships meeting the requirements from the Royal Navy. And one, we can say that in certain way, he played as well a crucial role in advancing the capabilities and ensure the effectiveness of the Royal Navy fleet during a period of significant geopolitical challenges and maritime competition. Joshua Humphreys was an American naval architect known for his significant contribution to the design and construction of the early United States Navy. And he was very famous for building the first 6 frigates for the US Navy. His designs revolutionized American shipbuilding and played a crucial, again, point in establishing the US Navy as a formidable naval power during the late 18th century and early 19th centuries. Joshua Humphreys was born in Pennsylvania, British American then in 1751, and he likely received, again, training in shipbuilding and naval architecture through apprenticeship, because remember that at that time it was not a proper education in the universities. All the education were done through the apprenticeships in the dockyards and in the shipyards. And the practical experience he was gaining in the shipyards along the Delaware River, where he learned the skills necessary for designing and constructing wooden sailing vessels. Humphreys became a prominent naval architect known for his expertise in designing warships, and he was commissioned by the US government to design and oversee the construction of a new class of frigates for the fledgling US Navy. These frigates were intended to protect American merchant vessels and assert American naval power of the high seas. Humphreys, the most notable work for Humphreys was the 6 first frigates for the US Navy, which were authorized by the Naval Act of 1794. And these frigates included the USS United States, the Constitution, the Constellation, the Congress, the Chesapeake, and the President. Humphreys' design incorporate advanced naval architecture principles, including an sleek hull design, heavy armament, and innovative rigging, which made them faster, more maneuverable, and more powerful than contemporary European frigates. Humphreys' frigate design were instrumental in establishing the US Navy as I mentioned, as one of the most important naval forces, and the 6 original frigates played a crucial role in defending the American interest at sea, protecting the American merchant shipping from piracy or harassing, and asserting American sovereignty in international waters. Finally, the last person that I would like to mention is Yamanse Bomanger Wadia, was an Indian shipbuilder, we can say shipbuilding tycoon, known for his pioneering working to the shipbuilding industry in India during the late 18th century and early 19th centuries. He founded the Wadia Group, a prominent shipbuilding and engineering conglomerate that played a significant role in India, maritime history, and industrial development. Yamanse Bomanger Wadia was born into a Parsi family in Surat, in India, in 1754, and he received training in shipbuilding and naval architecture through apprenticeships and practical expertise or experience in shipyards along the western coast of India, where he learned the skills necessary for designing and constructing wooden sailing vessels. Wadia established the Wadia Group in the late 18th century, laying the foundation of one of the India's most prominent industrial dynasties. The Wadia Group initially focused on shipbuilding, but later diversified into various other industries, including textiles, engineering, and constructions. Wadia introduced several innovations and improvements into the shipbuilding process, incorporating modern techniques and technologies to enhance efficiency and quality. And he was known for his meticulous attention to detail and his commitment to excellence, which earned him a reputation as a skilled shipbuilder and trust partner for the maritime ventures. We can say that Yamanse Bomanje Badia's spirit was the innovation, dedication to excellence, helped to establish this group that was pioneering force in India industry and commerce. So the individuals discussed above and the families, some of them were families, spanning from naval architects and engineers to mathematicians and business tycoons, collectively represent a diverse array of expertise and contribution to the respective fields. Their work, spanning different periods and regions, has had a profound impact, a deep impact on the advancement of the science, technology, and industry. Each individuals demonstrated a commitment to innovation and advancement within their field, and whether through groundbreaking mathematical theories, revolutionary ship designs, or innovative engineering solutions, they push the boundaries of knowledge and practice, driving progress forward. Many of these figures operated at the intersection of multiple disciplines, we have seen, bridging gaps between mathematics, engineering, science, and practical applications. This multidisciplinary or interdisciplinary approach often led to novel solutions and breakthroughs that had far-reaching implications across various domains. Their contribution had a global impact, influencing not only the immediate communities, but also shaping the course of the history on a broader scale, from the design of naval vessels that changed the course of the naval warfare to mathematical theories that underpin modern scientific understanding. Their work left an indelible mark on the society. The legacy of these individuals continue to inspire future generations of scientists, engineers, innovators, and their achievements serve as a testament of the power of the human ingenuity and the potential for individuals to make a lasting impact through dedication, perseverance, and visions. In conclusion, the collective contribution of these individuals reflect the richness and the diversity of human ingenuity, innovation, and collaboration. Their work serves, as I mentioned, a contribution to the power of individual brilliance and collective effort in advancing the knowledge, driving progress, and shaping the worlds we live in today. So I hope that you have not found very boring presentation. Sorry for the problems at the beginning. In the moment that I remove the movement of the slide, everything ran perfectly. And at least you get some information related with a particular personality. In future RINA presentations, I will prepare a third part and with more recent builders. And I would like to encourage the audience to look into the past to find the motivations to achieving greater things to the future. So thank you very much. And thanks to RINA and Keith for the organization of this event for the London branch.